Yep, so we'll hear from Amit now. Amit, are you ready to go? I'll stop sharing.
I am, thank you. So let me share my screen to get started. And Stephen, will you let me know if the screen's ready and visible?
Yeah, I can see it. You can go into presentation mode, maybe.
Got it. Okay, great. Well, thank you. All good. Are we good to go, Stephen?
Yes, yes.
Yes. Okay, great. Thank you. So good morning, afternoon, evening, wherever you are. I know we're spanning lots of time zones today. I'm in the West Coast here in the US, so early morning. So the goal today for me is to give you a really high-level introduction to this data model. We've done a lot of surveys, and lots of people understand what it is, but we also have, a whole population who seems to who are confused with this notion of a model, and it's understandable since it's such an it's a term that's so pervasive, and now you even have to qualify that it's a short language model sometimes. So I'll be doing an introduction on what the model is. It'll be sort of the high level view, and also talk, going back to basics of why we're doing it, and then how you could use it. And I'll also share my experience of how we've used it. So I am Amit. I've founded and run Altosphere, where we build a data platform for managing data from masts and other weather stations. So this is, I've participated in it since the start, like with Gibson and Stephen, and it's also sort of a core part of what in the platforms that we build. So to get started, the first thing is the talk today is based on a blog that I wrote last year. So if you prefer, you'll get copies of these slides, but if you prefer sort of long form text that you would like to browse, this is a good time where I'll take a very quick detour and say that all the work we've done lives on this GitHub page. For those not familiar, this is a page where we do have all the code, all the documentation related to the standard. And if you go to the discussions page here, you will see a number of, here's the blog that I wrote that forms sort of the background behind this presentation, but you'll see other discussion here. Example, the discussion around the digital certificate model, as well as all the meeting and notes. And I also highly recommend you maybe browse the issues page, both for some of the active topics of discussion, but if you even looked at some of the issues that we've closed, you'll sort of get a background into why certain decisions have been made on the regarding the data model. So it's completely open. Come in even if you have a question or if you have a feature request, just click new issue, start a new issue, or feel free to browse through what's already there. So back to the presentation. Let me do a slideshow here. So, what is a digital data model? So before I get into it, I'll say I know a lot of you understand what's going on here. This is for folks who are trying to just wrap the basic context of why we're doing it. So for most part, I'll just try and go through this pretty swiftly. I think this is maybe a 12 to 16-minute presentation. But please, if at any point you want to stop me and ask a question, feel free to do it during the presentation. Otherwise, I'll keep going through it. Otherwise, I'm more than happy to answer questions at the end. So why a digital data model? So if you take a measurement campaign out on the field, there's two pieces of data coming in. On the left is the 10-minute data, right? So if you look at it, you will see this data is the timestamped every 10 minutes. There's 4 columns, and if you browse it, you can sort of guess what they are. The speed at 60 meter, it's the average, and then the other columns are standard deviation, min, max. So that's what we normally think of as data and really what we're after. And then on the right is the PDF that gives you the context into what went into developing this measurement. So, where was the mass, what was connected to which channels, what kind of OEM sensor, etc. So on the left, you'd consider data. On the right, metadata. So metadata in the sense that it describes, how the data was generated. And the data model that we've been talking about so far, is really focused on how do we take this metadata and put it into a format that's easier for computers and analysts and any sort of analysis pipeline to operate on. And that's sort of the first confusion is, the question is, here's my CSV, what is the task 43 doing? So that's the main reason is task 43 is really focused on describing the metadata. Now let's look into this PDF report of sorts. Up until now, the main reason we get this data in PDF or in Word document or Excel, it's really for human readability, right? That's really its biggest pro. But once you want this data to move into, say, your database or some sort of QA/QC system, the first thing you'll need to have to do is to digitize it in some way. And that means lots of manual data entry, which then increases the chance of error again. And if you want to have any sort of QA/QC process that's automated, well, it's hard to do if your data is just coming in as a PDF or Excel file. It's not impossible, but it's a lot more work. So that's what forms the main goal of our data model is how can we take all of this metadata that describes each of your data columns, right? And how can we have an alternative format that's not just a PDF, but also another format that's much, much simpler and easier to move into a database or to move into, say, your Python script. So that's the main goal. And to enable that, what the data model does is it gives you two things. One, sort of standard naming conventions. If how do we describe, let's say, a logger? What is the right keyword for the OEM or the make model, the serial number? And second, which I'll show a little bit later, is how do you structure this data? Like, what are the different aspects of reporting? Different aspects of how to completely describe a mast or a floating lidar deployment. So first, let me talk about the first part, which is digitization friendly. So let's go back to this PDF screenshot here, and let's zoom in just to make an example into this particular section of where we're describing two sensors out on the field. And if you just read it, you can tell, say the first sensor is connected to channel 1. It's an anemometer with this make and model, this serial number, and at 80 meter. Now, the same information could be represented in a format on the right, which is what a JSON format is. So this already came up earlier. It's the JSON format, just to give you a very quick background, is that in some ways the de facto standard for how data is exchanged between, let's say, if you're using a browser application and a server application. So if you're using emails or anything, chances are this is the format the data is moving back and forth in. Just the built-in support for this format in lots of languages and databases is really high. So that's another reason, in addition to what Stephen described earlier. And if the same data was sent in this format, we could get that into a database in 1 or 2 lines of code. And this is what I mean by a digitization-friendly format. And this is the format that we recommend you use as to exchange data in addition to your PDFs or a Word document. So that's the first sort of recommendation coming out of this task force is, hey, let's use a format that's friendlier for machines to read in. The second is, okay, the format is there, but how do you structure your data there? So this is where, I think the data model sort of gives you a second piece of information you can use. So here's a busy chart, but if you just hang on to me and follow my mouse, here's the structure and how the mast, so let's see if you have a mast out on the field, how the data model maps all the information coming from a mast into a structure. So a mast in the data model, you could think of it as having 4 main branches, for example. The first one, and if I'm trying to follow my mouse if you can, is the basic details, right? That would describe the name, location, where, what are the coordinates. The second would be, what are the actual physical properties of the mast? Is it a lattice pole? What are the OEM serial numbers? Third would be, how do we describe the logger that's at the base of the tower that's collecting all that information? But and what else do we need to know? We need to know the basic make and model serial numbers, but we also want to keep track of the settings, like what's the averaging period, what time zone. All of these are, they don't make it into the time series tables, but these are important information. Like you want to be sure it's in the right time zone. Now, these three things are even before we've touched the measurements. Now there's a whole subset that goes into describing the measurements, and that would be what kind of details do we have around what exactly is the measurement, like wind speed, what height, what kind of physical sensor, the OEM model, and interestingly, even the calibration itself, which is every sensor before it goes out in the field, especially anemometers, are calibrated in the lab. We have a whole submodel on how to describe those PDF reports coming out from the lab. Then there is information around how is the mast mounted, how are the sensors mounted, and are there lightning or any other kinds of interference structures. And then finally, very importantly, how is each measurement post-processed in the logger? Like what are the slope offsets? What is the connection channel? So this is the high-level view or the tree structure of how the data model suggests you represent your data. And that brings me, so that's MAST was our first implementation. The latest one actually is floating lidar. And the first thing you can tell if I just go back and forth is, there's a lot less information you have to track for floating lidar. But to enable it, what we had to do, and this is where Stephen and all the team, we've gotten together and discussed this over months and months, is the first thing we've done is added much more expanded scope for measurements that you need for floating lidar. So that would mean, tracking currents at different depths and even supporting profilers that are downward looking, like the acoustic Doppler profilers that measure water current. So the structure of the data model, I think, has been flexible enough that we've been able to pivot and support, or not pivot, but expand and support floating lidars. And to do that, all we had to do was add in support for downward, more than one profiler present in a platform buoy, and really vastly expand the support for the kinds of measurement types we can track in a standard way. And the final thing I'll add to this is, if you are curious and if you're not completely familiar with what the data model is, or what does the data look like if it's tracked using the standard data format here, I recommend you go to our homepage here. And if you browse to demo data, Steven's just done a great job of putting what's a very realistic data set. So for floating lidar, we could put in here, there is a data set here. You can browse it here, and this should give you an example. But this can sometimes be a little bit verbose to read. And I would suggest you go into something like this, a tool that specializes in showing you the JSON format. And if you paste it in here, which I've done, you can see this information here. Right, so here is a floating lidar platform that has, a floating lidar deployment at this coordinate. If you look at the vertical profiler properties, there are two of them. One is an upward facing ZX300. The other one is a downward facing ADCP device. Right? So this is an example of how you can communicate what the, when you get that CSV file and you have all these data columns, this is the data format that could go together with it that will help completely identify and give you context to what was measured, what sort of device was measured. And finally, in the measurement point here, it shows you that, for example, if there's an 80 meter speed being measured, but then there are, another 20 sets of measurements here. So I'll go back into the presentation. So, I think in conclusion, I would say this is the main, instead of if you're looking to get started with a data model, I really highly recommend you look at these two examples and really start by editing maybe that to your use case, then maybe starting completely from a blank sheet of paper. So that's sort of ending the discussion what the data model is. how can you use it? The first thing I would suggest is if you look at the documentation for every piece of information, for example, to represent a mast, you need to represent a logger. I would suggest using the naming convention and the standard that the data model provides as at least your starting step. For example, if you look here, if you want to represent a logger, we suggest you call the model name the logger model name, right? Now, if you're starting in-house, you'd have to reinvent all of this. Maybe save that time and save that mental cycles that you would spend doing that by maybe using this as a standard, as the first pass. Second, if you do manage to represent all your data in this model, I would suggest, maybe if you're going to send a PDF or collection of your reports, time series to somebody else, maybe consider sending your JSON file with it so that they get the digital version of all the information you have. And now that we have support from Windographer and other tools out there, hopefully this is easier for you to do. And finally, and this would be for those familiar with working with databases, if you feel comfortable, you can even use the data model and the GitHub. It has all the code to start your own internal database. And if you're familiar enough, you could be up there by the end of the day today. The scripts are mature enough. So finally, we'll end with our internal experience. So as I hinted early on, at Altosphere, we build platforms for managing mast, remote sensing solar, and we build platforms where we manage the platform, but also sometimes a lot of our clients will deploy the platform into their own internal house. And from the start, like with Gibson and Stephen and Jason here, I've been actively working with the standard, and this is where I'll reiterate what Gibson has said is, I think we could have spent so much time and effort on this, but nothing would be as comprehensive and robust as the data model that has come out of this sort of joint cooperative open source work. So personally, I see this sort of culture as really encouraging. It's really fun to be part of because you get to talk to all your colleagues, and 100% what has come out from a group sort of joint effort is just a factor ahead of what probably we will come up with if we were just spending this time ourselves. And for our use case, the way we use it is, we have to constantly collect lots of logger data, right? So these are separate files. Then we get all the service reports separately. We get all the calibrations separately. And then all of it goes into a TAS 43 compliant data store, which is very strongly modeled after what's here, with the ultimate goal that when we share this data, we're sending a digitized version of the data out there. And then the real benefit of that is, say if you are just an analyst reading through lots and lots of service sheets and logger history and trying to understand what's going on, well, once it's digitized, you can represent it in a sensor history that's way more digestible, right? A 10-year history would be much more digestible if you show it in the right visualized form that's easy to digest. Number two, there's so much reporting errors, and I think this could be a blog or talk separately, is every time there's a small error, let's say we get a serial number wrong, the further you go in time and place from when that error occurred, chasing that error and patching it and making sure it's corrected is really, at least in our sense, we're almost working on measuring this, is one of the biggest sources of error. And having data in this digitized form really helps catch those errors early. And finally, since all the data is in a data store, we can process and correct it, literally with no manual effort. Like for example, we have all the calibration information, so you can apply that immediately. So one last thing is, so today we were hoping to unveil some tools that we're going to put out there publicly for open access and use. That would be tools related to how you can ingest data, whether it's loggers, comp sheets, or calibrations, and generate the open generate data in TAS 43 format. We're a little bit behind it, but we're looking for early adopters. So if you are looking or interested in being the first to try it out, before we make it public, you just helped a lot with also testing and debugging. Please drop me a note. My email's right there, and it'll be there at the end as well. So in conclusion, what I'll say is, if you are, say, someone who is internally looking to develop a platform or a software, please consider using the data model, as maybe at least giving it a first look to see if it solves most of the tools you're trying to put in place, at least from the database and the storage and representation format. Chances are it'll save you a lot of time, and just as importantly, a lot of your mental work. It certainly has for us, like months of time. And then finally, if you do get your data digitized, please consider sharing it with, together with your PDF and any other time series documents, so that, this standard and this model is really meant to enable wider and easier exchange of data. And by sharing it, you really help us enable that. So finally, thank you. Open to questions, and I know Daniel next is going to dive into more of the details of, how the data is represented and how that has helped him uncover issues and solve them. So I'm open to questions, but also happy to move on to the next one.
Great, thanks, Amit. It's brilliant. Any questions from the floor? Guillermo, yes, go for it.
Yeah. Thanks for the presentation, Amit. Really interesting. I think rather than a question, just a note. One of the things that I noticed when browsing the GitHub and trying to get up to date with the project, and one of the things I think you haven't mentioned, but I think it helped me sell it internally at Ocean Winds, was the capability to validate the inputs through the JSON schema file that comes along with the project. Maybe you could say some words to the forum for people that aren't familiar with it, because I think it's a huge plus and something that I think has flown under the radar in this workshop.
Oh, excellent. Thank you for reminding us that. So what Guillermo is saying is that, and what I'll maybe contrasted here is, so the data format does describe, the structure of how a mass should be represented, but there is also a file. Oops.
You're looking for the schema?
The schema there.
Folder? Yes, there.
Yeah. So we
this
do
schema
have,
file is the source of truth. This is
yeah,
the data model.
Right. And so, right. So we have a schema file here, which is a subsidiary of JSON as a format. But like Guillermo said, one thing we do here is for, let's say for any value in the data model, let's say a slope and offset, there is some basic amount of validation that goes there, like just to make sure it's a correct value. Like it should be a number, it should be between these ranges. So there's some basic built-in validation of values that you do get by default if you adopt this standard. And he correctly pointed out it's left out of here, but thank you for that feedback. That seems like has helped you put some validation in place.
Yeah, there's a nice simple website called JSON Schema Validator that you can put the schema on the left and your JSON formatted file on the right, and it just automatically does the validation. That's just a web tool. There's other Python libraries that have built-in schema validators for various different languages, and JSON schema is one. So you can easily, when you're loading in your JSON file, run it through that validation, and you can pick out quite a few different errors as a result and give feedback to the user to go fix them.
Yeah, no, great. And the one other thing I'll add about validation, and this is where I feel like it has added value to us internally, is one of the biggest sources of discrepancy in data always comes, at least to us, between the difference in information that's in the logger. Like even if you take something as simple as a serial number, if it's typed in correctly, right, you can check if if the slope in the logger is the same as the slope in the service report, and the calibration file. And a big source of issue there is when that is different at different places, for example. And now task 43 doesn't solve it immediately, but if you don't have data digitized in this format, then catching that, it becomes a manual work as opposed to an automated work. And that's, for example, one place where digitizing data, keeping it in this format, has just enabled us to make quite a big savings on time in there. So I'll leave you with that thought. And then again, finally, I'll just reiterate that if you're open to helping put out some open source tools there that we are preparing now and testing it, please, I'd love to hear from you wherever you are. It would help us a lot. So thank you again, and please feel free to email questions if you do have some.
Yep, great. No further questions. One last call. No. Okay, great. Thanks, Amit. Daniel, over to you.
Hello, everyone. Thank you for your attendance. I'm going to share my screen. I'm Daniel Nuno. I work as a data scientist at Eolos, and right now I'm leading our implementation of the metadata model. So first of all, first little overview of the model, and also a note, because this is all based on a real data example from a campaign we did for the New York State Energy Research and Development Authority. They made all the data publicly available, and you can download from the website. And I'm going to use that as an example, because it's a very good. It's a good example. So first, the JSON is has a hierarchical nature. So what we are going to see first is the project and site properties, then some sensors and loggers, the configuration about the devices, as you can see here, references, like if it's a mean sea level. This is especially useful for floating lidars because it can be mean sea level or lowest astronomical tide or any other. So it helps you to be clear about what are the data about. So afterwards, the types of measurements you can find, they are like physical properties measured in a physical location. So for example, here we have a wind direction. And this wind direction is measured at some point, 20 meters in that case, and it relates to the data column name, which is, in this case, is the same, but it could be another one. One thing interesting about this example is that the hardware tracking. This campaign had a problem, and we lost, the lidar stopped working, so we had to do maintenance and change the lidar. And this is interesting because hardware tracking it's also represented in the metadata model. For example, here we can see the first lidar information with its serial number, the lower firmware version, the dates from when it was active. And then besides, we can see also the second LiDAR with its dates. It also changed the firmware, it was updated, the averaging period, also a lot of information that we usually provide in a measurement plan or in a PDF, but as Amit has said, a PDF is focused on human readability, and maybe a data scientist or some analyst is going to prefer to have something that can analyze from code. Also, the software version, as I've said, it's also specified for all the devices in our buoy, as can be the IDCP or the lidar or every other sensor that provides measurements. More information that it's also in the metadata model is between the measurement points, which are the physical parameters we are measuring, and the column names. So we are going to measure a physical parameter, in this case, the horizontal wind speed, but we are going to provide you, the data is going to be some statistic about this. For example, the average is the usual, but you may be interested also in the maximum or the minimum or the standard deviation. Other data transformation that are also considered in the metadata model are, for example, tides, tide compensation or flow correction or motion compensation, which are things that are typical from a floating lidar, because obviously on a met mast you don't have any motion. And also, for example, maybe some client wants us to encrypt the data, so this metadata model can have the encryption key or encryption details. More specifically to floating lidar, some things that have been shown is the motion compensation, which right now we don't have it, but we are in developing stages, and tides compensation, which is also it's kind of motion compensation, a very low frequency motion compensation, but of course, depending on the site, it may be not really important, but in other places, tides can be have a very high effect. We also have vertical profilers, as has said Amit, that a floating buoy may have many. Typically, we have one lidar with many heights and one ICDP with many depths, but can have other sensors. For example, the wave sensor is also most typically from a floating device, which can measure the wave characteristics. And for example, one interesting thing we are starting to develop, and we have in some buoys, is the marine mammals and bird tracking, which might be key to understand the impact of wind farms. It allows to address and regulate some aspects of the design and construction of an operation of the wind farm. So you can take in account and try to minimize the effects, but more importantly, to know what effects do it have to the animals in the surrounding environment, which actually it's not really well known, and there is a lot to know. So we think it's a very interesting aspect that this metadata model allows us to better define what are we measuring, how are we measuring it, and to provide some context, given that this may be not the typical sensors that you can have in a wind resource assessment. And why is Eolos adopting it? We have traceability for the sensors. For example, if we have to change something or we have to change some configuration, but this provides an improved way to do it. And also it's a more transparent way to share this traceability with our clients. Also, I like it that along with the data, having this metadata package and the data, it's a self-descriptive package, and also allows us to have some kind of fleet data standardization, as maybe some clients might ask for some personalizations, or maybe different column names, or different number of devs, or a lot of different personalizations. And having this metadata model allows us to have some level of standardization, even though each way is different. Also, it helps to future-proof our data, because if you want to revisit data from the past, is going to be way easier if you have a clear way to know how it was measured and every other aspect of the data. More importantly is how does it help our clients, and there are many aspects. One of them is the ease to work with data. In one way, it gives confidence in what they are getting, how the data is acquired, and even what post-processings are we making, for example, tide compensation and motion compensation and other things. Also, it provides the clients to be easier to compare data from different sources, maybe different voice or even different data providers, as you can always have the metadata which is standard, and it works as a dictionary or translator. Also, as I will show later in a small script, it can help to check for data integrity and the comprehension of the data, and it makes more clear if there are datums, which reference are you using, the hardware configuration, sampling frequency, averaging period, and dates and the region. Maybe if you are giving the data with a timestamp that is end of period or beginning of period, this information is always given on the contract or in the measurement plan. But of course, it's going to be easier for a data scientist to have it in a model. More importantly, I think, is the aspect that it can save a lot of time. For example, many clients have a lot of questions which are typical, and many of them are also provided in the measurement plan, but anyways, maybe they don't. The person which contacts us doesn't have it, and wants to, or is not really clear and wants to concrete it. And also, it's, well, as I've said that before, it's not focused on human readability, but in the ability to access it through code. And obviously, even if documents are available and you know where it is, it's going to be faster and easier to access the metadata model through some code. And it can even avoid errors due to wrong references, maybe the true north or the geographic north. Also, I think it's very interesting that you can do scripts or automation code that can adapt to any other project that has this metadata model. As I will show in the code, you don't need to have any knowledge about your data, because you can have all the information about what measurements are there, which names, column names, and where are they measured. And also, I think it's important that the metadata model it implements a lot of some free fields, and it allows you to be more flexible. For example, at Eolos, we are thinking about introducing flags and other metadata, and even maybe validation results. Validation results are kind of similar to a calibration, which is considered in the metadata model, but they are not exactly the same. So we are thinking about what approach would be better. But for example, in the nodes, we can introduce a series of flags, and you could easily get in your code which flags are in your data, so you can parse it easily. Or, for example, validation results, as I said, we are not sure if we will put this like this, but this could be an example of how to do it. And let me show you a little example, a small script where I will show you how to use the metadata model so you can process or analyze data without any prior knowledge. So let me change. This code, it's everything, all the code is here. This function is going to be used a lot in the code. It's just a recursive function that searches for some fields in the metadata model. So I'm going to run all the script. And this is reads the model. And for example, we can list what types of measurements we have. The measurement types are which properties, physical properties are we measuring. It can be air pressure, illuminance, orientation, wind speed, wave, everything there is here. This is all the data that was available in the public data from New York. We also it's really easy. You can see it's just the elder function and one line. We can list all the depths and all the heights at which we have measurements. We can also list the measurement points, which are the names of the physical properties measured, or the column names. These are all the column names that you will see on our data. You can also see the sensors. One thing that is obvious here is that we have two lidars. As I said, these projects had an issue. The lidar stopped working, so we had to change it. And this example will analyze a little bit this. A very interesting thing is to check the basic integrity of your data. For example, here we load all the campaign data, which has a 10-minute resolution and a 1-hour resolution. And we can check if some column names are in the model but not in the data, and others that might be in the data but not in the model. And in this particular example, there was a typo. So the minimum wind speed should have uppercase S at the end, and it had a lowercase. So maybe this could be an error that could make you lose a lot of time not knowing what's happening. And thanks to the model, it's very straightforward. You identify that this column has a typo, and you can correct. We can also get the list of column names for the in this case, the wind speed. We look for all the column names which has a measurement type that is wind speed. And then we can even filter them by those that have lidar in the name and those that don't have. So this way we can have the column names for the horizontal wind speed at different heights thanks to the lidar and the meta station. This small function, it's just to plot a scatter plot and also a correlation. Initially, we will do it for the first two heights. And this is important that we don't have any prior knowledge of the dataset. I haven't introduced any column name, any knowledge. Everything is gotten from the metadata model. If I now run this code for another campaign with another metadata model, it will run everything right. And we can check, obviously, the horizontal wind speed at two different heights doesn't have to be exactly the same, but the correlation will be near. So this is for the full campaign, and one could wonder maybe if the first lidar, since it got broken, maybe it had some ground measurements before stopping working. So this could be interesting to check. And these two lines get the date ranges for the first lidar and the second lidar. And then we can also plot this correlation for the first and second heights of the lidar, for the dates of the first lidar and the dates of the second lidar. And this is the first lidar, which got broken. It's curious that there is this small well, it gets out of the mean, but we'll see that it's due to being two different heights, because, well, in the second height it doesn't appear. However, if I go back and I change, instead of doing this for the first and second heights, we can use the meta station measurements and the first height of the lidar. And now it looks very similar, but a bit different. And especially we'll see that now the first lidar doesn't have this strange thing. So we can now have a little bit more confidence than that the measurements it did while it worked were correct. In fact, the correlation from the first height of the first lidar with the meta station is a bit better than the second, which again doesn't mean the first lidar was best. It's just the correlation between two different measurements. Following the same line, we can describe some statistics about the first and second lidar. We can see the standard deviation or the mean of the horizontal wind speed. And another interesting thing, this, for example, gets the number of points in number of measurements that the lidar has in one day, which is gotten from the averaging period in minutes from the metadata model. And then we can plot the availability of all the measurements of the lidar at different heights. We can see how it's, well, here is when it started to stop working, and it was off for some time. Then we changed it, and we have here a gap, which is it's a mistake in my data, but I think the data from publicly available at the NISERDA web page doesn't have this gap. And that's all. I think it's very interesting that you can do a lot of things without typing any column name, without knowing anything about the data. And this can be used for any campaign, for any data provider. It's Eolos or whatever other company. So I think that the time savings for the clients and the Wayne community, it's very impressive. So thank you. And any questions?
Thanks, Daniel. That's great. That code that you've written, so you're saying you could apply that same code to another floating lidar that has the data model format, just loaded the data file format, and then just run all the cells and repeat everything that you did that EO6 one. Yeah.
Sorry?
You can just load in a different data model for a different floating lidar and just run all the cells.
Yeah, of
again.
course. Yes.
Very
And if there is a typo, like in this example, you would get it, and you would get the column names for any type of measurement. And I think also it's just a few lines of code, so it's great.
That's great. Any questions from anyone else? I have, while people are thinking. So if I'm a wind farm developer that's asked for a floating lidar from you guys, what would I be getting from you?
Well, first we will establish a measurement plan and ask you what you want, and this is going to be in PDF format, but we will also provide this metadata model with all the structure and the measurement properties and characteristics, and you could use it to get information about the data.
Yeah, so when you install the floating lidar, along with your normal package of delivery, you'll provide the data model. So then Gibson can take it and load it into his RWE platform and set up the station in his platform immediately. That sounds great. There's a question from Neil Adams. Do you want to unmute to ask the question, Neil, or?
Yeah, can do. Just yeah, really interesting example you worked through there. Just wondered if that notebook itself was publicly available, or is that in-house for you?
The data is publicly available. The metadata model is not, because we are, well, obviously it's implemented, but we are just polishing some final rough corners. It's a little bit more work, but we'll have it done in just 1 or 2 weeks, maybe. And well, since this campaign is old, I don't think that the client is going to put the metadata model anywhere. But if someone is interested, they can contact me and I will provide it. The data can be accessed easily, and you can Google it. You put Eolos NISERDA and it's quite straightforward.
I think is the notebook itself available?
No, the notebook.
To the public?
I could provide it. There is no problem. But it's not. It's just something I did for this presentation.
Yeah,
so much.
We'll see. We'll see about how
Maybe we
try
could
to
put it
the
on.
slides.
Maybe we could put it on the GitHub from Task 43 if there is interest.
Yeah, I think there's a tools folder, or can't even remember. Yeah, we can put it up there as well. How did you convince senior management that implementing this would be a good thing?
I didn't convince them because they already think so.
Right. Right. And what my other question then, if nobody else is asking a question, what were the challenges that you encountered adopting it?
Well, yes, a little bit because JSONs are quite. It's a very repeatable and very long structure. But at the end, what I did is thinking also in the future. I've done a script that uses a configuration file that we use for our post-processing. So not everything in the metadata model is in this file, but almost everything in the metadata model can be automatically generated from our configuration file that we use. And we already have it for post-processing purposes. So yes, there has been challenges, but hopefully they are near their end.
What advice would you give someone who's looking into it?
Clients or maybe data providers?
Just advice in getting to grips with the data model.
Yeah, I think it's a great thing, and maybe it's a bit of work at the beginning, but if you are going to work with wind resource data, it's going to save you a lot of time on the long run. So the faster you implement it, the more time you want to save.
Great, thanks. Any other questions? No? Well, we'll move on to the next section. Thanks, Daniel.
Thanks.
Jason is going to lead the Q&A and feedback, and this is going to be some survey questions. It's a different survey link to the one I had earlier on, because we realized that there's a 25 response limit because I have the free version. Jason's got a better paid version. So he's put the link into the chat already. Hopefully these survey questions will spur some conversation and discussion. So hand it over to you, Jason.
Excellent. Okay. Oh, sorry. So again, we'll utilize Poll Everywhere to do some facilitated feedback, but also welcome people to come off of mute, have a little more of a conversation around some of these topics, add things in the chat. We definitely want this to be interactive. Our goal is not to, limit any particular feedback. It is really to get all the feedback, as much feedback as possible about where the industry is at with adoption, how we can support you better in your adoption journey, and any new features and capabilities you'd like to see. So with that, we'll dive in. So yeah, we wanted to get a sense of your familiarity with the data model before this workshop. And I'll note we asked a very similar question in previous workshops, and I'm excited to say that I've actually added the the last response, which is I've already implemented it. Actually copied this question from a previous workshop. We didn't actually have that option before, so that's just an example of, I think, how we're maturing But so yeah, a lot of, almost a third to a half of people had either never heard of the model or had heard of it, but maybe didn't have that much information. Okay, great. So for those who are maybe in the adoption phase, I'd love to know where you're at with that.
For those that have adopted it, I hinted at the question earlier on in the first introduction that it's very difficult for us to know who's adopted it. So if you're willing to come off mute and just say, yeah, we've adopted it in whatever organization you're at, that would be great. Great to get that feedback and to know who has adopted it. There's definitely people that have adopted it, 22% of you.
Yeah. And maybe for those that are still deciding to adopt, again, we invite you to come off mute. How are you making that decision? Is it a conversation with your management? Is it looking at the maturity, looking at the other adoption in the industry? How are you making that decision? Might have to start calling on people.
You could phrase it a different way, Jason. It's like, has some of the conversations that we've had already helping you with the story that you need to tell senior management to convince them?
Yep, plan to adopt. Okay.
I'm
happy to talk briefly. I guess it's always a challenge if you, Rome Maloney, work at mainstream renewable power in Ireland, though we're a global company. It's always a challenge to switch from when you have something that works that you've had for some time. So I inherited a system that we built in, I think 2012, 2013, and it's worked pretty well. So we did implement a JSON import export ability, but we were sort of perhaps waiting on this. This predates me, a Windographer, to implement an import capability for the JSON data model. So let's say it's more that we have an existing system that can export and import the JSON data model, but that's not how the system itself works. So it's probably other people can relate. It's always a challenge when you have something that works. That are you going to switch to something else? What are the benefits of doing that? Is it going to help or hinder you?
Yeah, it is difficult to, once you got something that works, to change.
Yeah, I have a comment on that one because we had to go through that process ourselves. And then the question is, what can you do with your old system and what can you do when you get more of the metadata, because we also had exactly the same situation. And then the decision for the adoption was because there was so much more stuff. There was so much more metadata that you could capture, and therefore use your data in a broader way. That we decided then to make that change. And there was also a huge debate on whether we should write a converter to go from our old system to IA Task 43. But in the end, it was clear that it was much easier to start from scratch.
It's not fun work, is it? Trying to update a legacy system. I don't know if any of you have done that, but it's it's painful.
Nightmare.
Exactly, and that was the other thing, is that the energy for you to upgrade the legacy system that was built many years ago was so much more energy than starting from scratch, and I think upper level management may think, oh, this is working, you know, but the systems that were built for 10 years ago, they were built for storing data. You know, I think that the systems that, you know, what you can do with this is goes beyond data storage, because it allows you to create structured data. And I'm not sure, maybe the system that you guys have that was old also allowed that, but I think that's our experience in like also having an old system that having to go asking the questions on whether we should go to a transition.
I think a big sell of this seems to be, for me anyway, at least, is that is to keep in cold storage metadata. I know metadata changes over time, but it's you know, JSON is a great format that you could just dump somewhere along with your metadata files. I think that's a very attractive proposal. But as to whether or not you're actually going to change the guts of something you already have, maybe I'm not sure.
So, great conversation. We'll drive on here.
Jason, if you have a second there, I wonder, Rowan, that was a great point you brought up about whether the energy to jump ships from legacy to a new system. You know, we have a lot of people still waiting to decide. I wonder, is that one of the issues that's the hurdle on trying to decide whether to jump, is just trying to understand that transition, or are there other reasons for folks who are still in the trying to decide phase? Because that seemed to be like half the poll numbers.
Might I just add an extra point to that, Stephen? It's great to see Bright Hub developed. I think it's sometimes crazy to me that perhaps maybe we're all reinventing the wheel with these sort of duplicate platforms. So a bit of shared effort could save a lot of maybe human years or man errors if there's some sort of consolidation around that.
I hope so. I've had many years of banging my head, going through documentation, still doing it. So if we save other people doing it, that would be good. Thanks. I have a question about at least one person, if not more than one, has said they don't plan to adopt. I'd love to hear from that person or persons why. If you're, we won't take it personally. We love to learn. Someone would come off mute and tell us. Maybe we'll drag it out in some further questions. We'll plow on.
Efficiency.
Hi, Stephen. Hi, Stephen. Maybe I just want to share. I'm not in that fourth one, but I'm in the planning one. I don't want to identify myself here, but just a reflection here. Basically, we see that as the industry is moving forward for more megawatts in upcoming years, and wind industry, particularly renewable industry, is going to gain a lot of momentum. I think this naturally will trigger a lot of this kind of efficiency or this JSON related aspects will trigger more scalability into our way how we adopt things, rather than going towards reading the text, reading the PDF documents and having manual errors, value chain issues. So I think this is the way forward. I think there could be some issues in the current adoption phase, but this is the way forward.
Yeah, thanks for sharing. Yeah. If there's anything you need to help convince senior management or colleagues to adopt it, then just reach out.
Sure.
Yeah, so we're seeing a lot of signal around the efficiency and time savings theme, which is absolutely true. And we heard that from Gibson earlier, order of magnitude. I like this idea of transferability and the ability to reuse processes and tools. I mean, this is So we've been doing a lot of work looking at digitalization more broadly across not just resource assessment, but operations, turbine design. And this is one of the themes that we see about like the maturity of the industry is if we look at automotive or aviation or even the tech sector, not only have they, figured a lot of this out, they've also, especially the tech sector has built open source tools which can be leveraged. And so I think these themes of, reusable tools and stop recreating the wheel are really powerful. And I'm excited to see that people in wind are starting to kind of take up that charge. Reliability and built-in validation. Yeah. So, and this goes back to the like data maturity theme. So one of the things we're working on in Task 43 is really understanding what it means to be a data mature industry. That includes things like schemas, ontologies, data contracts, data validation, all that kind of stuff. So it's nice to see that resonating as well. Yeah. So we talked about the value. What are the barriers? Obviously, legacy systems, I think, are one. Andrew Black, I'm going to call on you. Oh, there we go. Yeah. What are the barriers, I think, for Vizsla? Love to hear your thoughts, Andrew.
I think one may be interoperability. Obviously, the JSON data model is attacking this directly, but there is also this proliferation of platforms. There could be variants of where there are subjective choices in data model types or parts of measurement campaigns that are outside the scope. So really, as the industry scales up, we need to think about, or we need to be quick on our feet and looking forward, looking to the future in terms of how do we accommodate competing platforms. Really, it's a good problem to have, frankly, as an industry. That, but one that will still take work to adapt to.
I think just on that, competing platforms, I think, are okay if they use the same data standards or use the data set to be able to transfer data from one platform to another. If they start creating a different data standard, then that's a problem, and
right,
that can cause problems.
Of course.
So clearly a word cloud maybe wasn't the best choice for this question. It's a little hard to parse, but I think the theme that seems to be popping out here is a lack of tooling to actually help that transition. So maybe that's something that we can focus on, Stephen, in the kind of coming iterations. I think there's a little bit of chicken and the egg feeling, which is understandable. I think that's true of any transition. Amit, you have a comment?
I do have a comment, and I'd be curious to see if anyone has any response to this. The one barrier I feel like I pick up on is this hesitancy around You know, for example, we here are very clear this is beneficial, but in some other places, I got kind of pick up a messaging that maybe, well, we already have people sort of spending their time doing this, and there's already sort of a process in place. There might not be a system in place, but there are people and a process in place. And is this really like that much better, or yeah, like if it's really that much valuable? And I wonder if that's a feeling anybody else has picked up on, is just, you know, not quite buying into the value, given that people are already, you know, like we already have teams to do this. So just curious if anyone has any feelings to share there.
Maybe I'll just add a thought to that, Amit. So in the backdrop of this, I think, and in the backdrop of all the digitalization work, is the fact that we need to scale dramatically to decarbonize. So a couple of weeks ago, had a presentation from a colleague at NREL, and we're looking at something on the order of just 10x wind deployment by 2035 to meet like basic decarbonization goals. And if you take a step back and you think about that, that's 10x installed capacity, you know, 10x actual turbines in the ground. But we all know that development isn't 100% hit rate. And so that 10x deployment is actually more like, you know, if you assume a 10% hit rate, that's more like 100x throughput on energy yield assessment processes. So can we actually hire that many people to do that much work and scale in that way? Probably not. I would say there's an actual imperative as a global society that we need to accelerate this using digital tools.
Yeah, I agree. It makes sense.
All right. Arthur, I see you turned
Yeah,
your camera on.
I was going to say, could I chip in and ask a quick question? So I'm joining here from a master installer and lidar deployment company. My managers and my questions really about it is that I totally see the point of the exercise for analysts, but it feels a bit as though it might transfer a lot of work to us to put the data into this system. For example, we have automatic tools that allow it prompt the installing crews to take photographs and make measurements, record serial numbers, and so on, which we would have to re-engineer in order to produce the data in this standard. Is that correct, or?
Well, what I would hope is that the logger manufacturers will step up and expand the information that can be put into the logger data files. So then platforms can read it in and just fill in the data model straight away. That would be great. There'll be some information that won't. So I don't know about how much re-engineering you'd have to do. As Daniel said in Eolos, it was kind of easy enough for them to adapt because they had all that metadata in their file system anyway. So they just need to export it. If you've got some system where all the data is stored in a database or something, then it might actually not be that bad for you to export, not change anything you've done already, but just kind of export it in the right format.
Yeah, and if I can add to this, I think that if as you mentioned, Stephen, if the OEMs, you know, mass lidars, floating lidars, they provide parsers, they make it available, then it's actually, especially for lidars, it's quite easy to go from, you know, that information in the data file, which is something that you can easily but in task53 format, and even extract also to a PDF, so you can have like an electronic version and like a written version. But that I think that piece is very important, is that the sensor manufacturers, the instrument manufacturers, that they make that available. Of course, I can write my own parser, but it's much more powerful when they write their parser and make available to the players in the industry.
So the main logger brand that we use is not a specialist wind brand. So I'm not sure if they would change their file format just for this, perhaps. So
well, it depends on whether they can expand on it, not change their file format, but expand on the metadata that's captured. And if they are not a wind specific logger, then it'd be hard to ask them to write an open source Python parser to parse their file format into the data model. But that's where we as an industry, an open industry, someone can write a parser and open it up, and then everyone else can use it.
I just thought it might be interesting to raise that side of.
Yeah, no, like the further upstream
the
data model gets filled out, the better for everyone else downstream. So
I mean, we're seeing clients asking us to consider starting using it, but those are the barriers we have at the moment, that it seems to transfer a lot of manual work to us that wind analysts did previously.
Yeah, and what we're hoping to do is make tools to reduce that manual effort for wind analysts and yourselves to not have to do that manual effort. So yeah.
Anyway, there we are. Thank you.
No, it's great. Thanks.
Thank you. All right. We may accelerate, just give it time, but spend a little bit of time on this. What would help you adopt the data model? Clearly, Arthur, thank you for that feedback. It's also nice to know that your customers are actually asking for this. But that's, specifically on the mast installer side, that's something that we've been thinking about for a long time. And maybe part of the next evolution of the work. So GUI tools, a parser tool. Yeah. Okay. All right.
I would have thought some people might mention tutorials or more documentation, so I'm glad they haven't.
Yeah, that's a good point. In previous iterations of this workshop, we got feedback around tutorials, so we spent a lot of time working on documentation on tutorials. More worked examples of tutorials. Okay. Excellent. Drive forward. Is there anything missing? I mean, obviously we understand there's maybe a tooling deficit right now. We think we can address that either directly through the task or through partners, but yeah, what new features or functionality? I think David mentioned some of the MetOcean stuff. Scanning lidar, that's an interesting one. Do you have any initial thoughts on that, Stephen?
I think it's a completely different data model for scanning lidar. The data model is structured as if it's like you got a point geographical location and you're looking up or down in case of ocean, and you're measuring the wind direction at points at that location. It could be expanded to scanning lidar is more of a wind map across an area, so it could be expanded, but I think it would be too different, and if it's scanning lidar might need to be slightly different data model. I haven't really thought in great detail about it, but it has come up a few times. So it's come up a few times. Again, feel free to write an issue in the issue log, and that gets it on our radar more formally to discuss in meetings that we have every second Thursday around this time, or an hour earlier than this on Thursdays usually. Jason's put the Slack channel invite there. Join that. Ask to join, or just email myself or Jason, and we can send you the invite.
So,
yeah,
and I think the scanning lidar one brings up the concept of ontologies and a wind domain ontology, for example, and how do we link different data models, which maybe it makes sense to have two separate data models for resource assessment, or single point measurements versus scanning measurements, but then linking those in some useful way. We're also doing a lot of work, or the industry is doing a lot of work around energy yield assessment modeling, data models, power curve models, all kind of stuff. So I think raises larger questions about how we actually make those interconnectable. And that's something we're also working on in Task 43. Okay. All right. Last question. Hopefully it's pretty easy. But yeah, was this workshop useful in explaining the data model? Tell us how we did. Awesome. All right. Well, thank you everyone for the feedback. I think this was really useful for us to hear your comments. Just a quick note on next steps. We'll be publishing the workshop videos to YouTube. We'll publish slides to the Task 43 website and to Zenodo. And of course, we'll continue developing and deploying the model with your feedback. So thank you for that. And of course, resources, the GitHub repo, Slack channel, our contact information. Thank you so much for being active participants in this. We hope it helped you understand the level of participation, the new developments in the data model. Stephen, anything else you'd like to say?
No, just I hope you found it useful, and thanks for sticking around. Probably some of you it's late in the evening. So thank you.
Yeah. Thank you, everyone.
Thank you. Really interesting.
And we're happy to stick around for a few minutes if you have any other questions, comments. Philippe, I think I saw you raise your hand.
Sorry, it was just a mistake. Wanted to just applaud and thank you for all the work you guys have done.
Thanks.
Thanks, Philippe. David? Maybe that was also
That was David.
Yeah, the exact same problem. I was trying to applaud.
Oh.
Excellent. All right. Well, thank you, everyone.
You can stop the recording now, I'd say. So are we sticking around, Jason? 6 o'clock.
I was just going to stick around for a few minutes.
Yeah,